Solar System exploring solar systems in the universe beyond our own journey. The term solar system paints a picture of our sun and the family of planets that orbit it. However, the concept of a solar system extends far beyond the boundaries of our cosmic backyard. In the vast universe, countless solar systems exist, each with its own star or stars, planets, moons, asteroids, and comets. Exploring solar systems is not just about understanding their individual components, but also about uncovering the diversity of planetary systems in the galaxy and ultimately the nature of planets and their potential to harbor life. In this article, we'll take a deep dive into the structure of solar systems, the types of celestial bodies they contain, the formation processes that shape them, and their significance in the broader context of the universe. Our own solar system serves as a blueprint for studying others. Centered around the Sun, it includes 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, as well as dwarf planets such as Pluto, numerous moons, the asteroid belt between Mars and Jupiter, and the Kuiper belt beyond Neptune. Types of stars in the solar system. At the center of any solar system is a star, which governs the dynamics of the system and provides its planets with the necessary heat and light. Not all stars are alike. In fact, the diversity of stars in the universe contributes to the wide variety of solar systems. Yellow dwarfs, red dwarfs, binary and multiple star systems, giant stars and supergiants. Yellow dwarfs. Our Sun is a yellow dwarf, a G-type main sequence star. It is in the middle of its life cycle, burning hydrogen into helium through nuclear fusion. These stars are relatively stable and burn for billions of years, making them favorable for life as we understand it on nearby planets. Red dwarfs. The most common type of star in the universe, red dwarfs are smaller and cooler than our Sun. These stars have long lifespans, sometimes up to trillions of years. Many exoplanets have been found orbiting red dwarfs, although the habitable zone, where liquid water could exist, is much closer to the star due to the low heat output. Despite their abundance, red dwarfs often exhibit stellar flares that can be harmful to the atmospheres of nearby planets. Binary and multiple star systems. While our solar system has a single star, many have 2 or more stars. These binary or trinary star systems can create complex gravitational dynamics. Planets in such systems may orbit one star, orbit both stars in a figure-8 shape, or even have highly elliptical orbits. The famous sci-fi world of Tatooine from Star Wars is an example of a planet in a binary system. Giant stars and supergiants. These massive stars are short-lived but incredibly luminous. Any solar system orbiting such a star would be subject to intense radiation and a short window for planetary evolution. Because of the rapid evolution of giant stars, their systems are often less stable and less likely to contain life. The formation of solar systems is a product of cosmic processes that begin in vast clouds of gas and dust known as nebulae. Over millions of years, these clouds collapse under their own gravity, forming a swirling disk of matter. At the center of the disk, a protostar forms, which will eventually ignite into a full-blown star through nuclear fusion. Around the protostar, the remaining material clumps together into planetesimals, which are smaller bodies that will merge to form planets, moons, and other objects. This process is called accretion, and it's a violent and chaotic time for any emerging solar system. Collisions between planetesimals are common, and only the largest and most stable objects survive to become planets. A planet's distance from its central star determines its composition. Closer to the star, temperatures are too high for gases and volatile compounds to condense, so rocky planets tend to form. Further out, in the colder regions of the system, gas giants and ice giants dominate. This division between rocky and gaseous planets is seen in our solar system, with the inner rocky planets, Mercury, Venus, Earth, and Mars, and the outer gas giants, Jupiter and Saturn, and ice giants, Uranus and Neptune. Diversity of planets in the solar system. The study of planets outside our solar system, known as exoplanets, has revealed a surprising variety of worlds. These exoplanets challenge our understanding of planetary formation and evolution, expanding the possibilities of what might be in the solar system. 1. Terrestrial planets. 2. Gas giants. 3. Ice giants. 4. Super-Earths. 5. Hot Jupiters. 6. Rogue planets. Terrestrial planets. These are rocky planets, such as Earth, Mars, and Venus. They are typically smaller than the gas giants and are composed primarily of silicate rocks and metals. They have solid surfaces and may or may not have atmospheres. Gas giants. Jupiter and Saturn are classic examples of gas giants. These planets are composed primarily of hydrogen and helium, do not have solid surfaces, and have very large atmospheres that extend deep into their interiors. Gas giants often have extensive systems of moons, some of which may be habitable. Ice giants, Uranus and Neptune, fall into this category. These planets are similar to gas giants but have a higher proportion of ices, such as water, ammonia, and methane, which are volatile compounds that freeze at low temperatures. Super-Earths. Super-Earths are a type of exoplanet with a mass larger than Earth's but significantly smaller than Neptune. These planets can be rocky, icy, or gaseous, and some are found in the habitable zones of their stars, making them prime candidates in the search for extraterrestrial life. Hot Jupiters, one of the first exoplanets discovered. Hot Jupiters are gas giants that orbit extremely close to their stars. These planets challenge the traditional model of solar system formation because gas giants are thought to form in the cold outer regions of a system. Their existence suggests that planetary migration plays an important role in the evolution of solar systems. Ice giants, Uranus and Neptune, fall into this category. These planets are similar to gas giants but have a higher proportion of ices, such as water, ammonia, and methane, which are volatile compounds that freeze at low temperatures. Rogue planets. Not all planets are bound to a star. Rogue planets are planets that have ejected from their solar systems and are now drifting in interstellar space. These lonely worlds challenge our definitions of what it means to be a planet and raise questions about how common such phenomena are in the universe. Moons, asteroids, and other celestial bodies. Planets are not the only important objects in the solar system. Moons, asteroids, and comets also play important roles in shaping the dynamics of their systems and potentially fostering life. Moons. Many planets, especially the gas giants, have multiple moons. Some moons, such as Jupiter's Europa or Saturn's Enceladus, are covered in ice but are thought to have oceans beneath them that could harbor life. The discovery of such ocean worlds has extended the search for life not just to planets but to moons as well. Asteroids. These small, rocky bodies orbit stars and often serve as relics of planet formation. In some cases, asteroids provide important clues about the early solar system. The asteroid belt in our solar system is one example, but the distribution of such objects in other systems may vary. Comets. Comets are icy bodies that originate from the outer regions of the solar system. When they come close to their star, they heat up and release gas and dust, forming a visible coma and tail. Comets can serve as time capsules from the early days of the solar system, preserving material from the time of formation. Exoplanet discovery. One of the most exciting areas of astronomy in the 21st century is the discovery of exoplanets. In the 1990s, the first confirmed exoplanets were found, and since then, thousands have been identified using a variety of methods. Transit method. When a planet passes in front of its star, it causes a slight dip in the star's brightness. By observing these transits, astronomers can determine the planet's size and orbit. NASA's Kepler Space Telescope used this method to discover thousands of exoplanets, greatly expanding our understanding of planetary systems. Radial velocity method. This method measures the slight wobble of a star caused by the gravitational pull of an orbiting planet. By looking at the wobble, astronomers can infer the presence of planets, their masses, and their orbits. Direct imaging. This is the most challenging method as it involves photographing planets directly. The brightness of the stars often overwhelms the faint light reflected by the planets, making this technique difficult, although advances in technology have made direct imaging increasingly successful. Habitable zones and the search for life. One of the most compelling reasons to study solar systems is the search for life. The habitable zone around a star is the region where conditions might allow the existence of liquid water on a planet's surface, a crucial ingredient for life as we know it. However, the discovery of subsurface oceans on moons such as Europa and Enceladus suggests that the habitable zone may not be the only place to look for life. The diversity of solar systems and planets presents many opportunities to find life beyond Earth. With the development of new telescopes and instruments, such as the James Webb Space Telescope, we are now able to study the atmospheres of distant planets and moons in unprecedented detail. Detecting biosignatures, gases, or other substances that indicate the presence of life is a major goal of future exoplanet research. What is a solar system? A solar system, also called a planetary system, is a collection of celestial bodies that orbit a star due to the star's gravitational pull. The primary star is often referred to as the Sun, and the system typically includes planets, moons, asteroids, comets, and other bodies. Our solar system is made up of the Sun and the objects that orbit it, including Earth and the other planets. How many solar systems are there in the universe? The exact number of solar systems in the universe is not known, but estimates suggest there may be hundreds of billions of stars in our galaxy alone, with many of those stars likely to have their solar systems. With billions of galaxies in the observable universe, the total number of solar systems is likely to be exceptionally large. What is the difference between a star and a solar system? A solar system refers specifically to a star system that contains a single star, such as our Sun, and the planets that orbit it. Star system is a more general term that includes various stellar systems, such as binary or multiple star systems, where two or more stars orbit around a single center of mass. What are the main components of the solar system? A typical solar system consists of star planets, moons, asteroids, comets, Kuiper belt and Oort cloud, star, the central body of the system, which provides the gravitational force that keeps other objects in orbit. Planets, large celestial bodies that orbit the star. Planets are classified as terrestrial, rocky, or gas giants. Moons, natural satellites that orbit the planets. Asteroids, rocky bodies often found in the asteroid belt between Mars and Jupiter. Comets, icy bodies that release gas and dust, creating a bright coma and sometimes a tail when close to the star. Kuiper belt and Oort cloud, regions of icy bodies and comets that lie beyond the orbit of Neptune. What is the habitable zone in the solar system? The habitable zone, or Goldilocks zone, is the region around a star where conditions are just right for liquid water to exist on the planet's surface. This zone varies depending on the star's luminosity and temperature. Planets within this zone are thought to have the potential to support life as we know it. How do planets form in the solar system? Planets form from the protoplanetary disk of gas and dust that surrounds a young star. Through a process called accretion, particles in the disk collide and stick together, gradually forming larger bodies. Over millions of years, these bodies can coalesce into planets. How many solar systems are there in our galaxy? Estimates suggest that there may be as many as 100 billion stars in the Milky Way, and many of these are believed to have solar systems of their own. This means there may be hundreds of billions of planets in the Milky Way. What are exoplanets? Exoplanets, or extrasolar planets, are planets that orbit stars outside our solar system. Thousands of exoplanets have been discovered in recent years, thanks to advances in technology and space telescopes such as Kepler and TESS. Can solar systems be found in other galaxies? Yes, solar systems can be found in other galaxies. While it is difficult to determine the exact number of solar systems in galaxies beyond the Milky Way, observations of distant galaxies suggest that solar systems are a common feature in the universe. How do scientists discover new solar systems? Scientists use several methods to discover new solar systems and exoplanets, including the transit method, observing the dimming of a star's light when a planet passes in front of it; radial velocity method, detecting fluctuations in a star's motion caused by the gravitational pull of an orbiting planet; direct imaging, taking pictures of planets by blocking the light coming from their parent stars; gravitational microlensing, observing changes in the brightness of distant stars caused by the gravitational field of an intervening object. What are the challenges of discovering other solar systems? There are many challenges to discovering other solar systems, including distance. Solar systems are incredibly far from Earth, making travel and communication difficult. Technology. Current spacecraft and telescopes have limitations in terms of range and resolution. Cost. Space missions are expensive, requiring substantial funding and resources. Are there any known solar systems with habitable planets? So far, there are no confirmed cases of extraterrestrial life. Still, several exoplanets have been found that are in the habitable zones of their stars, where conditions may be right for liquid water and potentially life. Ongoing research aims to find more such planets and investigate their atmospheres for signs of habitability. What factors are necessary to support life in a solar system? Factors that contribute to a solar system's ability to support life include stable star, a star with a stable energy output; habitable zone, a planet located in the habitable zone of its star; atmosphere, a planet with a protective atmosphere capable of maintaining surface temperatures and shielding it from harmful radiation; water, the availability of liquid water is crucial for life as we know it. What are some upcoming missions to explore other solar systems? Several missions are planned or proposed to explore other solar systems, including James Webb Space Telescope, JWST, launched to observe exoplanets and their atmospheres in unprecedented detail; Breakthrough Starshot, proposed mission to send small, light-powered spacecraft to the nearest star systems, such as Alpha Centauri, within a few decades. How could future technology improve our ability to explore other solar systems? Future advancements could include faster spacecraft, developing propulsion systems that can travel at a significant fraction of the speed of light; better telescopes, building larger and more sensitive telescopes to detect smaller exoplanets and collect more data; advanced robotics, sending more sophisticated robotic missions to explore the outer limits of our solar system and beyond. What role do private companies play in solar system exploration? Private companies are becoming increasingly involved in space exploration through partnerships with space agencies and their own missions. SpaceX, Blue Origin, and other companies are developing technologies for space travel, satellite deployment, and potentially interstellar missions.